So you have to be careful because sometimes in an expression is just a string of math things without an equal sign. So in this expression, 15x to the 2/3, you have to be careful because the only piece of this expression that has the exponent is x. 15 does not have an exponent other than 1. Technically, there's 15 to the first power times x to the 2/3 power. So we hardly ever see a 1 as an exponent because it's just not necessary. So if we were converting this expression to radical form, what we would do is we would leave the 15 and we would only convert the piece that has the exponent. So we're only going to convert x to the 2/3. Okay, so we have our denominator, which is going to come in front as the root. So this is going to be the cube root of x to the second power. So this is our converted expression. In this case, 15 is just called a coefficient. All right, let's try another example. In this example, we have several things that have the exponent. So all of these things that are grouped by the parentheses, they all get the exponent 3/4. So they all get to go underneath the radical. Now, since we have a rational exponent, our 4 is going to come in front as the root. So this is going to be the 4th root of all this stuff that's in parentheses. So I'm going to leave it in parentheses. And all of that gets the exponent 3. And finally, example 3. Again, notice this time we have a coefficient, 3. And then we have our base, which has the exponent. So everything in the parentheses is the base. So we're going to take our denominator of 2, and it's going to come in front of the base as the root. So the 3 is going to stay as the coefficient. And then we have the square root. So I'm not going to write the 2 this time because it's understood that our root is 2 if we have a square root. So we're having the square root of AB in parentheses to the first power. Now in this case, since our power is 1, we may not see that written. So you might just see the square root of AB, and that's perfectly fine.